Welcome to the Python tutorial. Today we are going to talk about number in Python. Number is a inbuilt data type in Python which is used to store a numeric value, which means that number are always used to store a integer value, not a string values. So this is all about numbers in Python. Now let us understand through a simple example. Here I opened a Python shell and now I'm going to execute some example of number. Here you can say I assigned a numeric value in a variable a. Now when I execute this, here we get the result 18, which means that the variable a is stored a numeric value. So this is example of number. And now as we know that Python support 4 different numeric type, which is a integer, long integer, float and a complex. So you already know integer and long integer. I'm going to explain you float and complex. Now for float, a equal to 17.6. Here this is a float value. Now when I execute this, here we get the result 17.6, which means that the variable a stored a float value. Now for complex values, a equal to 12 plus 45j, which means that 12 is a real part and 45 is a imaginary part. Now again while execute this, we get a complex value, which means that it automatically stored a new value which is a complex value. So this is all about a Python number. Now I'm going to explain you some method which is used in number. Now the first method is absolute method, which is ABS method. Now for that I'll simply execute the absolute method when I create a variable and giving the value minus 12, which is a negative value. Now when I print this value with absolute method, which is ABS and A, so here we get the absolute value, which is a positive integer value. So this is all about the absolute value. The next method is a ceiling method, which is denoted by CEIL. These functions are not accessible directly, so we need to import a module called a math module. Now initially I'm going to import a module which is math module. So now here I'm going to execute a program. After that I'll explain you what is a ceil method. So now initially I'm giving a value 12.23 and now I'm going to print this value using a math module. Here I called a math module. So here we get the result 13, which means that ceil methods are always store the smallest integer value which is greater than the reference value. So which is the smallest integer value greater than the reference value? I think 13 is the smallest integer value after the 12.323. It will not give you the float value, it will always give you the integer value. Or we can say that ceil are used to store a next step value. So whatever value you had given 12.24, 23, 98, anything, it will simply give you the next integer value. So this is a 13 is the next integer value. So now this is all about a ceil method. The next method is a floor method. Floor method is just similar to the ceil method. So initially we have to import a module math. Here I'm going to execute a program. After that I'll explain you. A equal to 12.23 and now I'm going to call this method. So here we get the result 12. So which means that floor are used to return the largest integer value less than the reference value. So which is the largest integer value which is not greater than this reference value? So I think 12 is the largest integer value. or we can say that floor are used to get a previous integer value as the reference value. So the previous integer value, then the reference value is the 12. So if you put 13.34, 14.4, we will get the previous integer value which is 13 or a 14. So this is all about a floor method. The next method is a exponential method. Exponential method is just similar to the math exponential method. So these methods are not accessible directly, so we need to import a math module. Here I imported a math module, and now I'm going to simply print a exponential value of 2. So here we get the result 7.38. So this is all about a exponential method. The next method is a maximum method denoted by max. So for that we don't need to import a math module, we can access directly. So a equal to max 12, 45 and 2. Here we print a value a. So here we get the result 45. So 45 is maximum inside this list of item. So this is all about a max method. The next method is a min method, or we can say that minimum method. For that a equal to min, and again you going the same variable. Here I'm going to print a value a. So here we get the minimum value which is 2. So this is all about a min method. The next method is a power method. The power method is just similar to the math method, which means that 2 to the power 3, 2 to the power 4, whatever we will give the power, it will simply give the result. For that I am going to simply execute the power method. So first we have to import a math module because these methods are not accessible directly. And now I am going to print a value POW, and now 2, 3. Here 3 is the power of this reference value. So here we get the result 8, which means that 2 to the power 3 is a 8, which is 2 to the power 3 is a 8. So this is all about a power method. The next method is a square root method. A square root method is just similar to the math square root. So for that we have to first import a module math, and now I'm directly going to print a square root value math.sqrt 100. So we get the result 10. So square root of 100 is simply a 10. So this is all about a square root method. The next method is a mod f method. Mod f method is used to get a integer value apart and a float value apart, which means that we will get the separate value of integer and a float. So now firstly I am going to import a module math, and now I am going to execute a program. After that I'll explain you. Mod f, I am giving a value 12.90. so we get the result here. This is the float part of this reference value, which is 12.90, and this is the integer part, which is a 12. So what mod f does, it will separate the integer value and a float value in different parts. So this is all about a mod f method. The last method is a log method. Log method will return a natural logarithmic value or a base value. So for that we have to import a module math, and now I'm going to simply execute a log10 value math.log, and here 10, and the base is also 10. Here 10 is the base, so here we get the result 1. So we know that log 10 is a 1. So this is all about a number in Python.